Okay, good day, guys. My name is Harjit Singh Bamra. I'm from Mumbai, and today I'm going to introduce you to PLC programming and graphics. Now, those who are familiar with the relay logics uh, will be able to understand this PLC logic program. It's nothing but it's relay logic is hardwired and PLC programming is a software. Advantages is like it's a soft program. The contacts, the timers, everything is software based. Whereas in relay based, it has to be physically wired. Any modification takes a long time. You have to do the correct wiring and then check the logic program. Also, the disadvantage in relay logic is since they are physical contacts, they erode with time and then difficult to fault find also if the logic is very complex and it's very time consuming. Whereas in PLC base, since it is a soft contacts, timers and everything is soft, so fault finding is easier, programming is easier. Any modification takes just a little time. You do not have any hardware connection, just a soft connection. So now I will introduce this PLC. So those who are familiar with relay logic is much familiar, but I will try to make a simple logic so that even those who are interested can learn this logic, and not only that, they can practice. Once you purchase the software from me, you can purchase it and try your own logics. One more advantage of this is that if you are working in an industry and you need to program some logic, you can program it here, check the whole program logic, uh, do some hazard on it and make sure that the logic what you are going to implement will work. So as it is not a certified logic, cannot be used in the industry. So but it can do wonders. You can just make the logic, check the logic, do everything and then implement it in your system, which is a certified PLC. So now guys, let's start our program. Now, this is my desktop. Now I will start. We have two programs to look into. One is the ladder logic program, the other one is the graphics. So first we create some ladder logic. So this is the program I am looking in. I run it as an administrator and the logic program will start. Okay, now guys, here what you see here is a lot of boxes here. Okay, I'll try to explain you what is this. Say this is a row 0. You can see here row 0. Up to 9 boxes are the inputs. The 10th one is for the output. Okay, row 1, row 2, row 3, row 4, row 5. You can go down as 498 rows. So 498 times 9, it's about 4000 plus components you can add. So guys, you can make a very huge program. But mind you, this is just a physical 32 input, physical coming from the field, and you can just take 32 outputs to the field. Believe me, it's a huge program you can make. Okay, so the rest are the flag bytes, timer, counters, everything is internal to PLC. Okay, let us see what this program is. From here there are inputs and outputs. Here these are the wiring diagram connecting the wires from one logic to another. Like for example, making an OR gate, connecting a wire, deleting a function, inserting a row in between if you have forgotten something, and then deleting a row if it's made by mistake. Okay. Then there is an edit mode and other things as we go around. We will see. So we'll start with this one by one. So now this one is just nothing but a NO contact of a relay. You can relay from 0 to 31. As soon as you put this contact here, a declaration form is generated to specify what is the function of this contact. It could be anything from pump on, pump off, door open, door close, whatever is in the process. Say level high alarm, level low alarm, whatever. So it could be connected to so many inputs: counter, clock, timer, flag, output. We are now dealing with input and output. Okay, so we declare this. As we know, the first, that's 0 to 32. So 0 and take. You can add a text here. A text, say pump 1 on. Okay. Now this will now not show here, but it will show when you take a printout of this. So you will know what is the function of this contact and where I have used it. I have used it when it is 0, it is pump off, and when it is 1, it is pump on. Okay, well, let's take another one of this. We take as input. Now if you are connecting input 0, so we connect input 1. Again I add any text. Okay, door open, close, door opens, close. Okay. Now it's again an input coming from the field. Now what we need is logic. Say an input 0 is 1, input 1 is 1. I need to, now these are the outputs. This is a normal output, this is a inverted output. So I take this one, I cannot connect here, it will tell you output only in the last column. So we do it here. Now this in outputs there are two things. It's an external output to the field, and when you select flag, it is internal to the PLC, which is not reflected in the outside world. Well, let's now talk about only input output. So I connect an output. Okay, output, as I said, is 0 to 31, that's 32. So we take output 0. Now what this output does, physically when you connect it to the PLC, this will drive a solenoid or any electrical output device. This is nothing but a relay contact output. So contact will close and open depending on the logic. So now this is the ladder logic we need. So what to do with the rest? Just connect it from this wire. Okay, now our ladder logic is complete. What does it say? Input 0 to be on, input 1 to be on, to get an output. We simulate this now. Here, like you can see, simulation mode, no hardware required. Okay, so what do we do now? We simulate this without any hardware. So that's the way you check your logic before implementing it on the hardware. So we simulate 0, see, simulate 1, the output goes to 1. So our logic is well defined and it is working perfectly. So when I end this, I say this 9. Now I want to show this on a graphics page. Since this is only one line, it's easy to see that, but let's go to the graphics page now and start the graphic again as an administrator. Now the graphics page will be invoked. So this is the graphics. Okay, you see a blank page here, and there's nothing much to it, but I'm going to edit and run mode. These are the open save the earlier program. You can save this once you make a logic. Okay, you can give it a name, whatever, and let's go to edit mode. This hammer is an edit mode. Okay, once I'm selected, click anywhere on the page, declaration form is generated. What does this declaration form tells you? It tells you a lot of details as to what you will see in the graphics. For example, now this declaration form is connected to input 0 of my ladder logic program. So when it is 0, it is false. When it is 1, it is true. And you can have various colors here. Okay, define your own colors for input 0 and input 1. But this doesn't make any sense, as you could already see that while programming we had told pump 1 on off. So here when it is 0, it is pump off, and here it is pump on. Okay, we can choose any color, but for the time being we keep it as default. This is a default color which will come. So as soon as I click OK, you will see the graphic is displayed. Okay, pump off and pump on. Now we close this here, make it side by side, and now let's see how the graphics work when the input is operated. So we run this program simulation. We go to the simulation. This is the run. We run this. Now you see when input 0 is actuated, you see the declaration what we had done in 0 and 1. You can see pump on. Okay, pump on, pump off, pump on, pump off. Okay, this is the how you make the graphics for a particular input. Okay, now let's put this one in the graphic, input 1. Again go to edit mode. As I told you, by default this page will open and it will be connected to input 0. Okay, now let's do one thing. Let's change this to line. Okay, then we rate door open and door close. Now I have to connect this to input 1. Okay, door open. Now let's connect the last what was output. Okay, output 0. Okay. Let's make it false or true. You can write the function of the output so that it will be clear when you operate the graphics. So now I'll show you how huge this program is. Now this you can connect it to input 1 up to 31. So let's connect it. So you see now this is a database which can be reflected in the graphics from input 0 to 31, outputs 0 to 31, flags. These are the internal flags to the PLC which can be generated internally and used internally, which will not be in the output real world actually. So it starts from flag 0. Up to 80 flags can be generated, and then counter 32 counters and 32 timers. As you can see, this is a huge database and very complicated program can be made. Later on I will show you a complicated program which I have made, and you will really appreciate the function of this PLC logic, which cannot be not only used for training but can be used even for making a real PLC of input output, and program the logic you want and use it in the industry as well. So now let's connect this to output 0. Output 0. Okay, now you are here, you are here. Now you can see when I input 1, you need to run this. Input 0, input 1, output 1. See here, output 0 is true. You see here on the LED of the simulator, output 0 was connected, so the output 0 LED here is on, as well as here it is on. Now this output 0 can trigger anything physical, like an actuator, a damper, a solenoid, a valve, whatever you can think about, whatever you have connected there. So this is the way now, guys, you have connected this. Now let's leave the graphics aside. Anything you do, right click, connect it. Okay, right click, connect it, declaration, fill the declaration form, choose your color and connect it to the right input, output, or whatever you have programmed. Okay, so that one will show. Okay. Now see, it's again did that, so we delete this. Okay. Now let's start some programming. Now we have used this input only. Let's go for the second one. Add a test on. Now this is normally close contact and from a relay. As you very well know, relay has one NO, one NC. This is NC contact. So I can again give this as an input 0. Okay, I show you how. Okay, let's make it as input 0. Okay, we run this. Now as you would see, because this is the reverse of input 0. So if I connect, now this becomes closed, this becomes open. So this is a NO contact. Now another way, like if I want another way, I will disconnect and show you one more thing. This one, I can duplicate input 0 as many times as I want. Unlike in the physical relay, there are maximum 4 NO and 4 NC. I can keep on adding as much as I want. So let's now say delete this. Okay, now we to this one. Okay, now I will now input 1. Okay, I'll input 2. Input 2. Okay, now as I told you, I can use it again as a flag output. Okay, I use a flag which is a flag 0. Okay, now I run this program. Now we are trying to make complicated logic in a row one by one using NO contacts and NC contacts. Now as you know, this input 0 and normally open, input 0 normally close. You see what happens here now? Since input 2 is normally closed, now flag output is on, but this is internal to the PLC. So now you see, as soon as I made input 0 on, contact has changed over. This has become closed, this has become open. Okay, this contact can be duplicated n number of times. NC can be duplicated n number of times. This is the real advantage of a software program compared to relay logic program. Okay, and we end this. Now we have made 2 logics and this and this, neither this nor this. This is a flag. Now this flag can be put here and output can be generated. Okay, suppose you have say 20 inputs which are in series. So you make contact here, one input 0, 1, 2, 3, 4, 5, 6, 7, 8. Make a flag and put the flag again here on this one as a feedback, and you can continue and keep on continuing. So this is the way you can make a big ladder logic. Okay, now we deal with later on. Now this is nothing but a reverse contact. Okay, I can add a reverse contact here and show you. Say output 0. So it's nothing but, as you run, you see it's a reverse contact. This is a reverse contact. That means input 0 not energized, output 0 energized. So this works as a reverse input. Okay. So even in the contacts, you can, as I said, in the contact you have normally open, normally close, and output relay contacts. This is for the inputs, this is for the outputs. So let's start. Okay. We'll come with this for this later on. The set flag. Set means mostly, if you are aware with SR logic, that means main input is one is set, and another input you will reset, but it should be the same outputs. Say if the relay is on for one pulse, the second pulse will make the relay off. Let's do that. Set flag. Take an input. Now we go for input 3. Okay, and we put a set flag. Now this again allows you to put a flag, internal or an output. So okay, let's take an output, say output number 1. Now guys, let's run this. Go set flag. Is input 3. This will set it, but now it has latched and it will not reset. So we need to create a reset contact also. Okay, now let's make this as input 4. Okay, and then we make a reset. Now here, since we want to reset the output 1, this has also, so we do v output 1 again, as you can write text here, output 1. So now guys, input 3 will set output 1, input 4 and reset output 1, and by default reset has the priority over the set, because when you start a program, the reset pulse has to be applied, so that all the flags, the timers, the counters, everything has to reset to 0 when, so that the logic program will function normally. So now let's make this simulation. Okay, as you see, as I told you, now the reset flag has to be always priority. Priority means it has to be always on, and power is applied to any logic. The advantage of that is, like, when, if some of the programs are on, some of the programs are off, and so when you just give us energize the panel, a reset pulse is given to all the reset flags, so then it gets the reset. So the program now can function normally. Input 3. Okay, but input 3 has to be pulsed. You see, once it is pulsed, you can remove that. Now it sets the output. Input 4 also does that. But as you see now, the input 3 somehow has to be pulsed. It cannot remain like 3 and 4. So you see, this is not allowed in the circuit. Okay guys, now we were left with the P positive pulse and the negative pulse. Okay, let's make a small logic with this by using these two functions. So for this we use one input as input number 8. Okay, and we need to make one flag here, say flag 8. Okay, it. So as input is on 8, flag 8 is on. Now here we refer this flag as a positive edge. This positive edge, by default this will be always a flag because it is going to be pulsed. So when input 8 is on, flag 8 is on, the positive edge flag number 8 will pulse, and we use one output here, set. From the set and reset we use the set. So let's make that as an output number 8. So yes, so then we connect this, and now you see how it functions. Okay, now as input 8 is on, you will set this flag. Okay. This has generated one pulse, this time not this one but this one, so you can remove this flag now. Set flag is set. Now we need to make a reset flag for the same output, so let's do that. Input number, say we take input number 9. Okay, and we generate a flag 9. Okay. Then we connect this to the flag. As I said, again we use this flag here, feedback out there, that's 9. Okay, and now we reset this. What do we reset? The same output number 8, this output number 8. Okay, now we connect this. Okay, now we simulate this. So as you see, the reset flag is on. In basically any electronics SR flip-flop, reset is always the priority. So when power is applied to the circuit, the reset pulse is given to all the reset flags in the system, so that the circuit becomes normal. So any counters, any timers are reset when this reset pulse is applied to them. So input number 8 will set this output. Input number 9 will reset this output. So this basic circuit is widely used in the logic for resetting and setting the outputs. So that covers most of our things here. Okay, this is just nothing but output normally open, output normally close, just a negative output. Okay, now let's talk something about, say, here. Okay, this is an OR function which has been already shown. This is a wire. Now this one is delete a function. It can delete it like highlight it, delete it, okay, and put another function, or you can directly put the function over it, it will delete, and put a new function like this. If you don't need it, cancel it and go back. This one is to insert any row. If you have forgotten some row which is the next row of this one, you can say insert row number 1. This will insert row number 1, and you can add any logic here. The same way applies delete the row. This will delete the row. If you have no need for one by one deleting, it can delete in one go. So guys, I've basically we have covered all of them here, and the next video will be about for function block, and these are the wire connections, okay, as I have already explained to you. Okay, now I minimize this now. Okay, minimize this. No. When you purchase the simulator software, what you will get from me? Okay. You will get training manuals, logic program booklet, logic program, each and every function explained. You will get the graphics program, what I have explained you, most of the graphics program. Coming back, business information. Okay, what will you get when you purchase the software? You will get an USB with the logic program and graphics software. Second one will be the software copyright protection dongle. So when you invoke a program, it will not allow you until you put this software dongle protection USB. You will get a software training manuals of training, free training online if required, and free off-the-shelf. And this is the contact address which you can note it down. Okay, I need to add even UAE mobile. You can get in touch with me also. 0097150731947. That's it. So you can take note of this, contact me either on this email. And so that's it guys for this, and be ready for my next video which will be advanced programming and advanced graphics. So see you in my next video.